Park Industries Web Video, Integrated Tool Management System, Part 1. The course objectives are to learn the needed values for the ITM, to understand what R values are, and how to fill out ITM sheets. If you'd like to follow along, you will need ITM sheets, some tooling to measure, and a caliper. ITM is a system developed to measure tools on the machine with a laser. The system allows tools to be adjusted for wear with minimal operator input. The ITM consists of both hardware and software to measure, update, and track tooling information. Integrated Tool Management. Renishaw is the ITM laser manufacturer. R numbers are values used by the ITM system to determine measurement locations. The gauge line is a location on the tool holder that sits at the end of the spindle. The tool diameter used by the machine is always the smallest diameter of the tool. The large diameter is used for ITM R values. The tool length used by the machine is measured from the gauge line to the location the ITM sets for tool length. The outline of a tool could be looked at as a map, like a map of Hawaii. If we add detail to the outline of Hawaii and ask someone for directions from the Kona Airport to Hilo by boat, we recognize the directions as distances going north, south, east, and west. This is how the laser should be guided around the tool by our directions. The directions we give are just measurements. Each R value specifies a distance. The most common misconception is that the R and R values stand for radius. R values are measurements needed by the Renishaw laser for guidance around a tool to take measurements. ITM sheets are useful in gathering information that needs to be entered into the machine. It makes it easy to organize tooling information for the tool library and the R values for the ITM. The top part of the ITM sheet is used to enter information into the tool library, and the lower part is used for ITM R values. ITM is only used on metal tools. The polishers are hand fit. R25 is a horizontal dimension from the center of the tool to approximately 0.063 from the edge of the tool, or 0.25 from the edge of the tool if the tool is a gauge wheel. Use a caliper to measure the largest diameter on the tool, divide that value by 2, and subtract 0.063, or 0.25 if it's a gauge wheel. Record the number, the same value, for each of the 4 metal tools. R23 is a vertical dimension from the bottom of the tool holder nut to the bottom of the tool. It's measured on every tool with a caliper. Place the tool on a flat surface close to the edge. Use the back side of the caliper to measure the distance from the surface to the tool. All 4 tools may have a different value. R24 is the size of a search window. Either 0.25 or 0.1 is to be used. Use 0.25 when possible. Use 0.1 on a small flat or on a radius. R9 is a step size within the search window. Use the value from R24 and divide it by 5. The top type of a tool has a perpendicular flat that is more than 0.25 of an inch. The value for R24 would be 0.25, and the value of R9 would be 0.05. The bottom tool doesn't have a perpendicular flat that is more than 1/4 inch. R24 would then be 0.10, and R9 would be 0.02. R26 is a vertical dimension from the bottom of the tool to to the bottom of the search window that was established in R24. It may be easiest to make two marks representing the search window on the tool, then use a caliper to measure from the bottom of the tool to the bottom mark made representing the search window. Enter the same measurement for each of the 4 tool positions. On more complicated tools, such as an OG bull, a formula can be used to find R26. Take the overall height of the tool minus the top lip plus the opening divided by 2, and then subtract the R24 or search window value divided by 2. Enter the same measurement for each of the tool positions. R21 is a horizontal dimension from the small diameter to the location you want to measure for length. First, determine where the tool should ride at the bottom of the stone. It may help to make a dot with a marker. Use the tang at the back end of the caliper to measure horizontally from the flat area within the R24 to the mark that you made for the tool ride height. Enter the same measurement for each tool position. The sequence of the ITM. First, the tool moves down to the laser to find the end of the tool holder. Next, it moves over using the values we recorded in R25 and R23 to find the bottom of the tool itself. Then it moves to the bottom of the search window using the value we input in R26. Then it steps in increments using the values we recorded in R24 and R9. Then it uses the value R21 to step out to find the tool length. We must choose to use either the largest or the smallest measurements from the results of the R24 search window. Within the search window, there are 5 measurements taken on every tool. Of the 5 measurements, do we want the largest value to represent the tool's diameter or the smallest value to represent the tool's diameter? Depending on the surface of the tool. On a tool with a large perpendicular flat, we would choose the largest. Therefore, the tool's scratches won't get embedded deeper into our material. On a tool with a curve being the diameter, we would choose the smallest. Therefore, the diameter of the tool would be close enough to our material to get our full profile. Some tools may require choosing a different R21 location. Tools that have a sloped edge should be treated differently. A slight variation in the R21 value might make a big difference in the ride height of the tool. As shown on the picture, a 0.1 difference in the R21 might change the height of the tool by 0.327. Instead of referencing the R21 to the desired ride height, we can pick a flat spot on the tool and then use a default Z offset to shift the ride height to our desired location. A value in the Z offset will change the ride height of the tool from the tool length established by R21 or R22. The need for a Z offset varies by the profile. Cutting without a Z offset, the measured Z0 on the tool will ride at the Z0 or bottom of the stone. Adding a positive value in the Z offset register will raise the tool by that amount. R22 is only used on encapsulating tools that are symmetrical. Using R22 will center the opening of the tool on the material thickness. If the thickness of the material is 3 cm or 1.181 inches, half of the material thickness is 0.591. To calculate R22, use half of the opening plus 0.03. This value usually equates to the material thickness divided by 2, which as we learned before was 0.591 plus 0.03 is the value for R22. This value should be the same for all 4 tools. The 0.591 value can be important on a bullnose. It can be used to calculate R22, and it can also be the value used for R21. When using R22 to measure a tool, it measures the entire opening of the tool. This sets the Z0, or the ride height, to the middle of the opening. Because the ride height is not at the desired location, we again have the need to use a Z offset. On the encapsulating tool, the measured Z0 becomes at the middle of the opening. If we cut without a Z offset, the Z0 will ride at the Z0 on the stone. If we use a Z offset with a value of half the material thickness or 0.591, the center of the tool will ride on the center of the material. The Z offset value should be entered into the tool library section of the ITM sheets. The offset value should be the same for all metal and polishing tools in a profile set. Thank you for watching.